is that I will tell you. If the, I'm just starting with this, okay? If the period number is n, then it will have first case, if odd, then 2 into n plus 1 by 2 whole square elements in it. Okay. Second case, if even, then 2 into n plus 2 by 2 whole square elements in it. If you are just bamboozled by what I have written, you are not getting any idea about where is this for, then remember this 1, 2, 4, 5, 6. These are the periods, and in the first period we wrote how many elements? How many elements are there in the first period?
Sir, there are 2 elements.
2 elements. Then the next one is
8.
8. Then the next
Again
one
8.
is again 8. Then
18.
18. Then
Sir, again 18.
18. Then
32.
32. Okay, fine. Choose any number between 1 to 6.
Sir, 3.
3. Okay, fine. So we have got 3. Then this is plus 1 because this is odd, divided by 2 whole square into 2. So this will be equal to 4 by 2.
2.
Whole square into 2. This is equal to 4 by 2 is 2. We cut
So
this.
8, 2.
2 is
So
2.
8,
2 square.
16 by 2.
This will be 8, right?
Yes, sir.
Now choose an even number.
Sir, even number 4.
Even number 4 plus 2 by 2 whole square into 2. That will be equal to 4 plus 2 will be 8 by
8,
2.
2. Sir, 6 by 2.
2. Yes, this how much?
6 by 2.
6 by 2. How come 6 by 2? This is 6. Sorry. Oh, okay, fine. Yours. I thought you were answering me. Yes, sorry. It will be 6 by 2. 6 by 2. So this will be equal to 3 square into 2. That will be equal to 18.
So this will be 18.
Fine.
Yes,
So
sir.
now, my question to you is, just select these whole thing that structured upwards. Okay. Now, my question to you is, if this is the trick or generalization for the number of elements, what will be the generalization for the number of orbitals? Or if I may ask in a question type, then how many orbitals can be filled in the third period? This is very simple, okay? Don't go here and there. This is very simple.
1 minute, sir. I'm writing this down.
Okay, fine. Okay, write it down.
So how did you get these formulas?
I had this formula in my mind. I guess when I was in 11th standard, then only I came up with this or something. Or and then I forgot it because I was not in touch with this chapter for a very long time. So after yesterday's class, I sat down and I started to see the pattern. And it is very interesting. You get, I guess, in WhatsApp also you get very much WhatsApp forwards. What is the pattern? What will be the next numbers? I don't know you get or not, but we have a group with our professor here, and we share these things. So it's, what can I say? Mind exercise, feels fun also. So I came up with this again. Nothing big. This must have been taught by some other teachers also. I mean, I don't think I am the only one who has came up with this formula. Others may also have this formula.
So
Okay.
imbecile sir didn't make me write this formula.
Okay. English answer didn't. Okay. I'm also one of his students. I didn't. Yes, this was not because I joined in the 12th standard, I guess.
Oh,
Hmm.
so sir, you are currently.
I am doing masters in chemistry.
Oh, okay, sir.
Yes, and my specialization is in computational chemistry.
Nice, sir. So sir, what are you planning to do after this?
My let us see where things go. I don't plan so much.
Okay, sir.
So let us just see. I'm doing this computational chemistry and also some things on nanocellulose. So I have some projects going on in my college, and if those work out fine, then it will be fine. And teaching is always there.
Yes, sir. So there will be 4 orbitals.
In the third period, yes, right. There will be 4 orbital. Great. So what you have to do, you have to just remove this 2 from here, and you will get the number of orbitals. Okay,
Yes, sir.
right. Okay, fine. So I think
So I did it. So I did it by like number of electrons half is equal to number of orbitals.
yeah, it is same. But if you want to generalize it, then you just remove this 2,
Yes.
and instead of getting the elements, the output you will get is the number of orbitals, right? Hmm.
Yes, sir.
We started with S block, but I guess I think we will have
So
this
you
block
gave me
again
a
today.
homework of atomic number 114.
Yes. Did you come up with the answer?
Yes, sir.
Yes.
Sir, it was Renon with 7s square,
Hmm.
5f14,
Hmm.
6010, and
Hmm.
72. So
Hmm.
seventh period, P block, and
Hmm.
14th group.
14. Okay. Yes. True. So again, you are doing things what Mendeleev did, right? Predicting things. But 114 is always is already there. Now take a question. Uh, just imagine, like if maybe in later days after 30 years, 40 years, 50 years, you will have more elements. So the periods will add on, right? Then calculate the number of elements that can be accommodated in, let's go crazy, in the 10th period. Yes, you can tell, don't have to solve. What was the formula? It was n plus 10 is even. So n plus 2 divided by 2 whole square into 2, right? You started solving.
So 72.
This will be 10 plus 2 by
So all
2.
this time I thought I was in mute.
Okay. 10 plus 2, that will be 12 by 2 square into 2. This will be equal to 6, right? Then 6 square into 2. That will be equal to 36 into 2, 72 elements, right? Okay. Let us start again with the S block elements. Yesterday I think you didn't get much of idea. Okay. So first of all, I will start with this sodium metal only. Okay. And the reaction of sodium with water, H2O. So we have sodium Na, which is solid. Then we added sodium in H2O. H2O is liquid. Now, what are the products that we are going to get? The only assumption that I am asking you to make is just this statement: oxygen has the tendency to attract electrons. Okay, I'm
Yes,
just
sir.
asking you to assume this thing. Other things you know already. What are the other things that you know? You know about sodium metal Na. It has a tendency to lose electron. So it will go for Na. It will become Na positive. Why positive? Because it loses an electron. Okay. Yuvraj, can you explain me how this is Na positive and how this positive charge arises? I mean, very precisely and mathematically. Only a plus charge. Why only a plus charge?
So cause it is an ion and it has to give electron to combine with.
So why not two positive charges? And what was here that it was having no charges? I mean, it had already electrons, right? So it should be negative
So
charge.
cause it has only one
But
valence electron in its last shell.
so no, I'm asking why it doesn't have any charges here. It has electrons, right?
Yes, sir.
If it has
Okay, so
electrons and electrons are negatively charged, so it should be
why the atom has no charge?
yes, yes. Hmm. Okay, fine. Nothing to worry. Just listen this. Listen to this. This is important. Most of the time, see, there is no issue. We even no nobody taught me this also. I mean, why this is if this has electrons, then why not it has any charges? It goes to very basic point. But what are humans? Humans should always be reminded of basics. Sodium. The first thing about sodium is that it has 11 electrons, right,
Yes, sir.
which are negatively charged. But in addition to that, it has 11 protons, right? It has
11.
11 protons. So these protons are positively charged, right? So if you
Yes.
have 11 negative and if you have 11 positive, that would make it 0
Neutral. Yes, sir.
neutral, right? But what happens in this case when we lose an electron? What happens in
It
that
will
case
gain
is,
positive charge.
yes, now it has how many? It has 10 electrons.
One positive charge.
Yes, and it has 11 protons, right? It is very
Yes.
simple, but most of the students, even in your class, will stumble upon it and they will be just numb because they don't have this idea and they are not reminded of this idea. They know they're in their subconscious mind, but they have not been reminded. So it will be positive charge. Okay, very simple thing, but need to be reminded. Okay, fine. Now let us move here. So we have Na plus and electron. Let us erase this Na, right, and this. And also I will select this Na plus and let it move a bit apart from the electron. Move the electron a bit. Right there. Now we have H2Os. What I said was oxygen has tendency to attract electron. So if I have oxygen somewhere here and it is bonded to two hydrogens, right? And I said it attracts electron. That means it will have some delta negative charge Delta, you must be knowing delta from physics classes. It means minute quantity, right? And if this is delta negative, this will be delta positive, right?
Yes, sir.
So what is the thing about nature is that opposite charges attract each other, right?
Yes, sir.
So what will happen now? Now what will happen is this oxygen will, this H2O atom will orient itself in such a way that it is near to the oxygen part of the H2O atom is near to Na positive. Why? Because it is attracted towards this delta negative charge.
Yes.
And similarly, what will happen? Similarly, there will be some atoms like this H, O, and again H, and there must be Na plus here, right? Now this is delta negative, this is delta positive. Now what hydrogen is thinking is that hydrogen is thinking oxygen is taking all my electrons, and I have got a free electrons in my vicinity, very neighbor. Okay. So what happens if some friend of yours doesn't give you any kind of respect or something, and you get a bit of respect with some other friends? What happens? What happens is that you go with the new friend more easily and more comfortably. So what happens? Hydrogen is like, okay, fine, see oxygen, I'm leaving you. I've got this electron here, but what does oxygen say? The shared pair of electrons that we first shared, I'm going to take these also. Like, okay, fine. See what happens in a divorce. In divorce, what happens if person A is divorcing person B, then person B says, okay, fine, I'm not divorcing you. All the assets that we have in together as a family, I'm going to take that assets if you are going to voluntarily leave. The same thing happens here, right?
Yes, sir.
Same thing happens here. The hydrogen is saying, I'm going. Oxygen is saying, okay, fine, you go, but I will take the electron. So what happens? Hydrogen, it goes away with a positive charge. Now it has an electron. It accommodates electron. So now it becomes H neutral, because first it was positive, now it is neutral. Now what happens to our OH? It becomes OH and the negative charge. Why negative charge? Because it gained an electron from the shared pair of OH bond, right? So we
Yes.
have an OH minus here and we have an H. But this is not the only case. We have only one or two H2O atoms. There will be multiple H2O atoms, and the H atoms and other H atoms will join together and they will make H2 gas. What happens with H2 gas? H2 gas liberates, right? It is a gas, so it leaves. So what remains is H2 has left. So I can write the reaction H2 has left, right? Plus I have got Na plus ions. It is just wandering about in the solution. So we have Na plus, and I also have OH ion. Na plus, which is a positively charged ion, is wandering around, and OH negative, which is a negatively charged molecule, and it is wandering about. Then what will happen? They will come together, and they will be like this: Na plus and OH negative in vicinity. So what we write, this type of thing, which are dissociated but in a close contact, we write it in AOH, aqueous. This aqueous, what does this signify? That they are broken apart, but they are in the vicinity, right? The only thing about this whole exercise was to tell you that when we obviously Na is an alkali metal from group 1. What happens if we put some group 1 element in water? It increases the concentration of OH negative ion, and that is why metals behave as bases in water. Did you understand now?
Yes, sir.
Okay, fine. So this was the thing about S block that we needed to cover, and we did group 1 and group 2, right?
Yes, sir.
Okay, fine. So can I now move to P block elements?
Yes, sir.
P block elements. Okay, fine. So if we start with P block elements, first thing, what is the first thing that we should know about P block elements?
The general
Like,
configuration.
yes, the general electronic configuration. P block elements. What will be the general electronic configuration?
Sir, NS2 and NP126.
NS2, NP 126, NP 126.
Yes.
So can you tell me what will be the group number?
Sir, group number will be so 13
From
to
where to where?
sir 13 to 18.
Yes, and if you don't remember, then just see, you have
Sir,
got the
I
general
did
electronic
10.
configuration.
Sir, I did 10 plus 3 electrons, then 10 plus 8 electrons. So
Yes,
that's all.
10 plus 3 is exactly right. That is the way, that is the thing that you have to develop. Okay, group 13, I'm very glad. Group 13 to group 18. Fine. General electronic configuration. So first of all, we will learn the group 13 elements.
Yes, sir.
Group 13 elements. What are the group 13 elements? Do you remember it?
So atomic number 5.
Okay, fine. But what is the atom there? What is the element there?
Sir, 5 was boron.
Yes, right, boron. Okay, fine. I'm telling you I'm giving you a hint. How I remember it. I remember it like this. Bag it. Now, can you remember?
Bag it.
First is boron.
Second will be atomic number 13, so aluminium.
And you are very much well rehearsed with the 2, 8, 8, 18 one. Okay, 13. Fine. So aluminium, Al. Then
Sir,
it will be helium.
31. I don't know what 31.
Okay, fine, great. If you are remember, see what is in the name, as William Shakespeare said, what is in the name? The thing that we call rose will still smell sweet if we call it with some other name, right? So
Yes, sir.
31, you know the basic thing that the sweetness part, you know the atomic number. Okay, fine. The next is indium, IN. The next is thallium. We write thallium as TL. You should remember the atomic symbols, but you also should know the names. So this will be boron. This will be aluminium. Remember this name. Just keep the indium. This will be thallium. THAL, I guess. Thallium. Boron, aluminium, gallium, indium, thallium. This will be 31 after 40. 49, right? You are on mute if you are speaking. This will be 81.
Sorry, sir. 81. Yes, sir.
Yes. So how you, if you don't remember it, then you can remember it like this. Bag it. Okay.
Yes.
Or else what you can say is Bowler. This is, I got it somewhere. Bowler Ali. Bowler Ali gave instant tea. Bowler Ali gave instant tea. Bowler Ali gave instant. Now T you have to remember just like T. TL not T. Did you note this down?
Yes, sir. 1 minute, sir.
This is thallium TL. We also call this as the boron family. We also call this as the boron family.
Done, sir.
Done? Great. So you wrote this. How do we have to remember it? The mnemonic. You wrote it right.
Yes, sir.
Okay, fine. Now tell me what will be the general. What will be the electronic configuration in this form?
Sir, in which form?
This NS1. You just have to add the N here. What
Oh,
will be
okay, sir.
N?
So
Hmm.
it will be for boron. It will be sir
It is
H.
five. Yes, please. Sorry.
It will be H and 2s square and 2p1.
Hmm. You just have to remember this. 2s2. I don't know why so many students want to join this class. No, no, 2s2 and 2p
2p1.
2p1. Now this aluminium will be
So aluminium will be 3s2 and 3p2. And
gallium,
then 4s2, 4p3, 5s2, 5p4, etc. etc.
etc., etc. You have to write this also.
So 5s2.
You write it down in your notebook. I am writing down it here. Okay, fine, it's fine. You don't have to
Yes.
speak. This will be okay. Fine. I just wait a second. Wait a second. This is one only. 2p1. We are going down the group. It will not change the number of electrons. If we go in a period, then we will change the number of. We
Oh,
are changing
yes,
the right. We are
yes.
changing the n only.
Yes, so this is the 13th group. Yes.
Yes. 6s2 and 6p1.
Done, sir.
Done. Fine. This is group 13. Now we will have group 14. Group 14. Fine. Where should carbon, silicon. You calculate the atomic numbers, okay? Silicon, germanium, Sn. This is tin, then it will be Pb. Write names: carbon, silicon, germanium. And this is tin. This is tin, then this is lead. How to remember it? Can simple Germans can simple Germans snore in pubs?
Done, sir.
Did you calculate the atomic numbers of all of them?
Yes, sir. So it would be 6,
Yes.
14,
It is 6. This will be
14,
14.
32,
This will be 32.
50, 82.
Then it will be 18. Yes, 50. And
80,
then
82.
82. Yes, correct. And the electronic configuration?
Sir, so from it would be the same as previous one, but we'll keep SP2.
So what will be here? We'll
So
start with
this will be 2S, 2, and 2P, 2.
then.
3S2, 3P2.
Have you written this down in your notebook? Write it down in this in
Yes,
your
sir, I
notebook.
did.
Yes. So this will be 3P2, 4S2,
4P2.
4P2, 5S2, 5P2. This will be 6S2, 6P2. So these are the kind of periodicity that you will be getting, right? Similar kind, just we are increasing the shell number and the outer configuration is same. And is this mnemonic okay? Can simple Germans snore in pubs?
Yes, sir.
Okay, fine. You will be remembering, right? I can ask you at any point in these classes, what is group 14 elements? So what we will call this group 14 elements?
Can simple Germans snore in pubs?
The name, no, I'm asking what the name. Carbon family.
Oh, okay.
Carbon family. Okay. Okay, fine. So what is the next group? The group is group 15. Group 15, right? So I am starting nitrogen. Nitrogen has just N. Nitrogen, then any idea?
Sir,
Any
phosphorus?
idea? Yes, it is phosphorus. Oh my God. What can I
No,
put
sir,
in?
not after that. So atomic number 33 and 51 and 83.
I was just now adding one more one from the earlier groups.
Yes, sir.
This is bismuth. Yes. Yes, still, please tell me. This will
Sir,
be 7,
7, 15, 33, 51, 82, 83.
33,
So 33, 51,
1,
and
and
83.
83. Yes. And this is nitrogen.
Nitrogen, phosphorus,
Nitrogen, phosphorus. This will be arsenic. Arsenic. This will be antimony. Antimony. This is bismuth. It is in brackets just to separate it from the other letter that we have written. Now, how to remember this? How to remember this? You know England, right?
Yes, sir.
The merry old England. What is peculiar about West is that let us take a city, Birmingham. We will end with Birmingham. Birmingham. Do you know Birmingham? Have you seen this Peaky Blinders?
Yes, sir. Sir, I know
Peaky
Birmingham.
Blinders. They are from Birmingham, right? Now remember this whole group 15 by Peaky Blinders. Where are they from? Birmingham. So what do they own? They own a pub, which was in the last period, right? And if
Yes,
somebody is in the pub, what happens? They are not sober, right? They are not
so
sober. So no place. Wait a second. Sorry. No place as sober Birmingham. Why it is not sober? Because the Peaky Blinders they own a pub there. Right? What we'll call the nitrogen family. Now tell me the electronic configuration. What should I write here?
Sir,
2s2.
2s2, 2p3.
Yes. And
And
then now
sir,
for
3s2,
phosphorus.
3p3 continuous Lect.
Yes, 3s2. If you are not saying, then please I will ask you to write it down in your notebook, because these are important and you will be needing these in the chapter which is called chemical bonding, just the next chapter after the periodic properties, right?
Yes, sir.
2s2 and 2p3. Now if you see something here, you just remember, I think you can remember by it anyway. For C, in this group 13 elements, right? What is the electronic configuration? The
Sir,
only thing that you have to remember is NS2,
yeah.
right? You just remember 2. Now subtract 2 from 3. What do we get?
So from 2 from 3, we'll get -1.
I mean, no, no, no. If you subtract 2 from 3, if you take 2 from 3, what do you get?
Sir, 1.
Yes, we write it like this, 3 minus 2. But what do we say? We are subtracting 2 from 3.
From 3, yes, sir.
So now you got 1, just fill that 1 in the p orbital. Now again, you have got here 4, you have got here ns2 already, you have got here 4. Subtract 2 from
4,
yes, what will you get?
2.
What you will do with that 2?
Put it in P.
Yes, great. Now here, nitrogen family, what do we have already? We have
5
2s2.
minus 2.
And now you don't say 5 minus 2. Otherwise, in other classes, you will be making a mistake when somebody will ask you. If you subtract 2 from 5, you will say minus 3, not minus 3, right?
So subtracting 2 from 5.
What you will get?
3.
Yes, 3. What will you do with that 3?
Then put it in P.
Yes. And you will get 2p3, 3p3, and 4p3, etc. Right?
Yes, sir.
And how will you remember this nitrogen family?
Sir,
No?
by no place as sober Birmingham.
Yes. Why Birmingham is not sober?
Sir, cause it is not sober. Sir, cause everyone remains drunk.
No. By the orders of Peaky Blinders, they have a pub there.
Yes,
Yes.
sir.
Now let us move to group. Group.
Sir, group 16.
Yes. Group 16. Right. So now, first of all, we will say the electronic configuration. Okay. What do we
Yes.
have here?
Sir, oxygen. So 8.
No, we have 6 here. So what you
Sir,
will do? Electronic
sir,
configuration. First electronic.
subtract 2 from 6.
Yes. So what
So
you will get?
there 4 which will be put in P.
Yes, you will start with 2s2, which is always there in the first element of any group in the second period. That is 2s2, and we will write 2p4. This 4 came from subtracting 2 from 6.
Yes, sir.
Then we will have 3s2, 3p4. We will have 4s2, 4p4, 5s2, 5p4, 6s2, and 6p4. Now you will tell me the atomic number. What will be the atomic number here?
Sir, atomic number will be 8, 16,
8,
34,
16,
34,
34,
52,
52,
84.
84. Now, say, wait a second. Where is the eraser? The eraser. Us se tepo. See how easy this is. O S say te. Oh, you just have to pronounce what these elements are, nothing else.
उससे टेपो.
Yes, that's it. Okay, no much worries. Now, what is this oxygen? Oxygen. What is this? Sulfur. Sulfur. And what is this? Selenium. Selenium. What will be this?
Sir,
Tellurium. What will be this? This will be polonium.
sir, do we have to remember all this?
Yes, you have to remember everything. Each and everything which is being taught, you have to remember it. If you didn't have to remember it, then why one would be teaching it? Correct?
Yes, sir.
And what we will call this? What we will call this?
Yeah,
This family will be known as,
oxygen family.
yes, oxygen family. Oxygen family. Also, we call these whole elements, this group, as chalcogens. Chalcogens. Why chalcogens? Because oxygen and sulfur, oxides and sulfides, they form ores. Fine. So these majority of the time, these two are ore. These two are ore forming elements. Hence the name chalcogen. Okay. And how will you remember this whole family? Just remember the pronunciation, how you will pronounce this group.
उससे
Us, se, te, po. Right?
yes, sir.
Now, moving on to the next, that is group 17. Group 17. So start with the electronic configuration, right? What will be the electronic configuration?
The 9, 17,
Electron. Okay, fine. Okay, fine. I know you know all these atomic numbers by just adding one to the previous group elements. But tell me the electronic configuration. It will be 2s2,
so 2s2 and 2p5.
2p5. Then this will be, oh my, 3s2,
3p5.
3p5. 4s2,
4s5.
4p5. 5s2, 5p5. 6s2 and 6p5. In 2s2, what we will write here? We will write here F. F stands for fluorine. What is the spelling of fluorine?
Sir, FLOURINE.
What?
FLORINE.
No, FLUORINE. Fluorine. I don't know how one should remember this. Fluorine. Okay.
Yes, sir.
Now, what will be the other one? Fluorine. Cl for chlorine. Bromine. Then, don't remember this. Iodine and astatine. This is chlorine. This is bromine. This is iodine. This is astatine. Astatine.
Team.
Yes. Now, please, your favorite atomic numbers.
The 9, 17,
9, 7,
35,
17, 35,
53, 85.
53, and 85. Correct. You want any You want any mnemonic for this one, or you can remember it? But if
So
you
I
want a mnemonic, it is very good mnemonic. I
which
hope you like it. I don't know. Let us see. First class biryani in Australia. Indians are everywhere.
yes, sir.
Okay, first class biryani in Australia. See what, and this is the Florine family. This is the Florine family, and also known as halogens. They have their own name, halogens. This is everything. Did you note this down? And the previous
Yes,
ones also?
yes, sir.
Okay, great. Now going to the last group of P block elements, which is group 18. Okay, now we have 2s2, 2p.
2p6,
Yes. Now we will have 3s2, 3p6, 4s2, 4p6, 5s2, 5p6, 6s2, 6p6. Now, but we have one more, and that is helium. Write helium in the top, and then we will start from here. Why helium in the top? It is just 2s2. Everybody remember it? Yeah, helium, hydrogen. Now, the next is,
sir.
please.
Neon,
Yes, neon.
sir. Then argon,
Yes, argon.
sir.
Then
Krypton,
krypton. Then
xenon, and xenon.
xenon and radon. See, if you are remembering these, then you also should be remembering the previous elements, the lower elements of the groups, right? In the previous elements, this is helium. Just to, for the sake of tradition that we have made by these 6 groups, I'm writing the names here: neon, argon, then we have krypton, then we have xenon, then we have radon. Okay, what
Yes,
else did we use to write? Did we write? No, we didn't write. What? Okay, fine. Now you must be very happy, right? I mean, the sequence of number that I am going to write it here must be giving you so much of dopamine in your head. See the sequence that I'm going to write. The most lovely sequence of numbers that you will be seeing here, right? What will be here?
sir.
Neon,
10,
neon 10, then
18,
18, then
36,
then
54,
54, then
86.
86. I mean, these are very important numbers, and the more important number are those, the difference between these numbers, right?
Yes, sir.
So you want a mnemonic, or you remember this, right?
Yes,
Or
sir.
if you, even if you want a mnemonic, then I can give you a mnemonic. He never he never arrived. He never arrived. So what happened? If he never arrived, something must happen. Karen exited with Ron. He never arrived. So what happened when he not arrived? Karen exited with Ron. Fine. So we have completed the P block elements. Now just a moment, and we will revise it. Okay, okay, fine. I won't revise it. I will start with a new slide. I will ask questions. I will ask. You have your notes with you, right? You have written all those things. This
Yes,
one
sir.
also. Did you write this group 18 one?
Yes, sir. Yes, sir.
Why did you not ask the name of group 18? We've written the name of everything.
So,
This will
called
be,
these are noble gases.
yes, these are noble gases. Why noble?
So cause they have they have complete shells.
So what? Okay, fine. One more question. There are two nobles, right? Are they noble gases or are they noble gases?
Sir, first one.
Why first one?
What is the difference?
You don't know the difference.
No, sir.
Okay, fine. Do you know the Nobel prizes?
Yes, sir.
Do you know what are they? I mean, how the Nobel prizes came up with and who gives them?
No, sir.
No, you don't know. Okay, fine. Your next homework. Homework. Study and tell me about Nobel prizes and its founder. Okay, this is your homework. You
Yes,
have to tell me about the Nobel prizes. You should know about Nobel prizes. Okay, fine. For now, I will say that I'm just erasing this homework, but remember this homework. Okay. I
yes, sir.
mean, you can, if you want, you can write it in your copy. These are noble gases. Why noble? Noble means that they are very noble. What is a noble person? Like, if you define a noble person, is that they don't react to situations, right? I mean, they give a response of some kind. They are very calm and they don't react. In the same way, these elements were thought to be not reacting when they were given the name noble gases. But sometimes what do we do? You know, right? I mean, some people give their children name very sweet names, but when they get older and older, then you come to know what kind of sweetness they have, right? So same thing happened with the noble gases. I mean, the previous chemists, they were very much, I would say, naive when they named these noble gases, because these noble gases were just discovered. And if we are saying just discovered in the human language, we can say that they are just born. So you cannot name something when they are just born. You have to wait some. If they would have waited, they would never have named them noble gases, because this xenon, we will come in next chapter only. In chapter 3, we are calling this noble gases. In chapter 4, we will be reacting xenon with several things, and we will be seeing the structures and electronic structure, the molecular structure of xenon compounds, of various xenon compounds with fluorine and oxygens, right? So what is the point here? The point here
Yes, sir.
is you should not name children very early. You should wait a bit, right? This is what happens when you name some things very early.
Yes, sir.
Okay, fine. Now going to the next slide. Tell me the, I've written this selenium, right? Tell me the atomic number.
Sir, selenium 34,
Yes, it
group
is 30.
oxygen.
No, oxygen, right? If it is 34, which group?
Sir, 16.
16, right? 16th group. See, now just close your eyes
Okay.
and keep answering. Keep yourself mute, on unmute and answer. This is in 16th group. So 16th group, and it is in P block. So I will write something like S2, right?
Yes, sir.
I will write S2 and then P. What we will
S2
do?
and P4.
P4. See, you don't even have to see now, right?
Oh, yes, sir.
Yes. Now the only thing that is left is the shell number, but you don't have to worry so much about shell number. Like, you can open your eyes in a while, but see, you know this thing, the electronic configuration. What
But
is the
the atomic number is 34, right? So,
yes,
N
34.
would, so N will be, what do you say, 4.
Yes,
For
see, 4, because it is coming after 18, and 18 is for argon.
uh,
Argon is in the third number. See,
yes, sir.
this is the kind of comfortableness that you have to bring with chemistry. Like if I said selenium, okay, fine. Say T4 that is in oxygen family, and oxygen family is in the 16th group. So 16th group, that means I have to subtract 2 from 6. And I know Salim sir said if we subtract 2 from 6, we write it 6 minus 2, and we will get 4 and not minus 4. So I will what we'll do with that 4? We'll put it in the P4. And then we will have 4s2 and 4p4. See? Now, can you see the importance of our good old quantum numbers?
Yes, sir, very much.
Yes, very much, right? So now let us go with this drill, and let us see iodine. Tell me the atomic number.
Sir, sir, iodine was in group 18, right? No,
Hmm.
sir, it was in group.
Iodine, wait a second, don't see. Just listen to me. Iodine. Does it rhyme with any other? What are the rhyming names of element that you can come with iodine?
Bromine,
And
chlorine,
and
group 17.
see, this is the way. Like if you want to answer something, go with the logical way. If you will try to remember everything, then you cannot hold. And even if you remember everything, they must be in your brain cells, but you will not be able to retain it. So what you have to develop, you have to develop a path from which you can retain the information from your brain. So if you see iodine, okay, fine, something rhyming. I mean, if you just start, then you will be getting the retention points very easily. Iodine, it is in group 17, and if it is in group 17, we know that this will be S2, and if it is S2, then then we will subtract the 2 from the 7. That will be 7 minus 2, and we will get P5. Correct? So
Yes,
this is the sweetness, right? If I don't know the valence shell, but I know the valence electrons. What is the valence electron? It is 7.
sir, valence electron is 7.
Yes, 7. See? And if you just now open your eyes, then you can tell that this will be in
Sir, 5s and 5. So n is equal to 5.
n is equal to 5.
Fifth period.
Yes. And if you will, this is fifth period, and you just have to know the atomic number. Now, some things you have to remember.
Sir,
For
P
example,
of 17th group.
yes, that is the fluorine. Yes, the
Yes, sir.
first element. What is fluorine? Fluorine has
Sir, fluorine has.
it has the atomic number 9. You have to remember this.
Yes,
Okay, there are some things that you have to always remember, and the people who said that don't memorize, है ना? These are wrong things. I mean, I mean, a person, for take me as an example, I would be very glad if I remember each and everything. Because what is understanding? Understanding is also a remembrance, right? Because if you don't remember something, then you don't understand it also. Because for understanding, you must be able to explain it, and if you are able to explain it, that means you are remembering it, you are retaining it. That is also a kind of remembrance, right? So never put down people who can remember. You have to remember some things. For example, the ABCDs. I mean, at any point, you cannot say, I forgot some letters from the alphabet, English alphabet, the Roman English alphabet, I forgot something. You cannot never tell that, right? So, for example, like that, you have to remember some things. That is the atomic number of the first element of each group. Okay?
yes, sir.
Right. So if you remember it now, then you will be remembering only and only, I would say, some 20. I mean, say randomly 20 elements and their atomic numbers. I mean, 20 is a number less than 26, and 26 are the alphabets in the English alphabet, Roman English alphabets. You have to remember even less than that, right? And the nursery students, they remember 26. Class 11 student must remember at least 20 with numbers, right?
Yes, sir.
Now you have to remember the first 20, I would say, and then first 20, I would not say first 20, but 20 elements in some kind of randomness. Fine.
Yes, sir.
Okay. So now we will go to our next block, that is the D block. Now D block is something that the class 11 student they fear very much. Why do they fear? I mean they don't know anything about the D block elements. Okay, fine. Chlorine they don't know. Okay, fine. Oxygen, but they have heard oxygen. P block elements, some things we have heard in the previous classes in our matriculation. Nitrogen, okay, yes, I heard nitrogen. Carbon, we had a chapter full of carbon in class 10th, right?
Yes, sir.
So, but what happens in D blocks, they are afraid. They are very much afraid. Why they are afraid? They are not comfortable. So the only point now here is to make yourself comfortable. Now let me start with D. The D block elements. Before going to elements, what we will first write? We will first write its
So first I is general configuration.
yes, general electronic configuration. General electronic configuration. What will be its general electronic configuration?
Sir, D block will be, sir, n-1 D from 1.
Before that, we will be having NS,
Sir,
NS,
NS.
NS2,
Yes, sir. Sir,
N.
but some in exception cases we even get
Yes,
NS.
that is exactly. What did you say? Exception,
Yes, sir.
right?
Exceptional
And,
cases.
and what it is written here?
General electronic.
General, right? So we are talking about generally what happens.
Okay, sir.
Right?
Sir,
We are
NS2.
talking generally what happens. What do people say? People say that generally Indians are very good at maths.
Yes, sir.
Generally, but are all Indians very good at maths?
No, sir.
But still we say so. That is why here general electronic configuration is ns2 n minus d 1 to 10. Correct? This is the general electronic configuration. The next thing that you should remember is these are mostly metals. These are mostly metals.
Better.
Okay. And the other thing that you must remember is what is the first period with the D block elements? Any idea? What is the first?
Sir, sir, atomic number 21.
Yes, atomic number 21. And which period? Okay, fine. You were saying that, so you can write it like this 0 to 2. Okay,
Yes, sir.
fine. So 0 to 2. Yes, it will start with 21. If 21, then which period?
Sir, it's 21. Then, what do you say? Sir, it will be third period.
Yes, correct. Third period. Right. These are mostly metals. And the thing that you must have seen that we have the S block here, then we have the D block here, then we have the, wait a second, we have the P blocks. I mean, this is the rough periodic table that we have, right?
Yes.
These are the S, these are the P. You have seen these are S blocks are harsh metals, right? I mean, they just lose electron. If you put sodium in water, it will start ignite fire. The P block elements are usually non-metals. You have seen that we have chlorine here and chlorine wants to, it has a tendency to attract electron. That is why they make NaCl kind of ion bond, right? And these d block elements are in between. So in a way, what chemists thought, fine, that means d block elements, in d block elements we are transitioning from metals to non-metals, right?
Yes, sir.
Hence the d block elements got a name, transition transition metals. Okay, so note these 3 points, then we will start with the actual elements of B block. Done?
Yes, sir.
Okay. We will start with, you have to remember this, Sakti Vikraman, Sakti Vikraman, Feko Nikuzen. I mean, there is a subtle difference in Feko and it is Nikuzan. Sakti Vikraman, Feko Nikuzan. And this is the first period of D block elements. And these D block elements are called transition metals. So this is also called the first transition series. First transition series. Okay. So how to remember this? Now you remember these Sakti Vikraman, Pekonikusan. Can you remember this? If you repeat
Mm,
after me, Sakti
sir, I
Vikraman,
can.
Pekonikusan. Most of the time, what I try to make, if I have a mnemonic, then I try if it is just made up with the elements name, right?
Yes, sir.
Sakti Vikraman, Pekonikusan. And if you remember this first transition series, you can now make up the groups. What you can do? You can now
Make
make
a
up the groups. But before making up the groups, what I will do is, sometimes what happens, we know the symbol, but we not know the name. The name is also important. Scan. What is the name here? Scandium. What is it?
candium. Candium.
Scandium. Yes, Scandium. And what is this? This is,
Sir, titanium.
yes, this is titanium. Titanium. This is vanadium.
Vanadium, chromium, magnesium.
Neum. This one is,
mag- Uh, this is chromium.
this. People often come here. Now they are just wondering, manganese or magnesium.
Manganese, manganese, not
Mag
magnesium.
This manganese. This is iron. This is
Iron. This is cobalt. This is nickel, copper, and zinc.
copper and zinc. Now, just after SC, we have here YLA. Wait a second. I have to have some space in here. I should draw a line. That would be better. Wait a second. For the eraser, draw a line. if I draw another line, and one more line for their names, and then another large spaced line for the elements, and then a bit smaller spaced line for the name of the elements, like this. Okay, then we have Scandinavian YTLA and one more, but I don't need that. This much is fine. Yes, so let us start. Why this is known as yttrium? What it is known as? Yttrium. Remember yt and trium. Yt
Ventrium.
trium. This is La. La is lanthanum.
You know.
Lanthanum. Then next here it is AC, and this is, what is this? Actinium. This is
Actinium.
actinium. How to remember this? Second year, let's buy AC. Yeah, or else you can remember second year, love AC. Okay?
Yes, sir.
Second year, write that down. That is important. Second year.
Sir, what is a transition series as in?
I mean, this is first transition series. This is the first period of the D block elements, right?
Yes, sir.
And the D block elements are called transition metals.
Yes, sir.
So we named it first transition series. It is just a name, nothing else. Okay.
So is it the same as 3D series?
Yes, it is the same as 3D series. You can also call it 3D series. And why it is called 3D series?
Sir, cause it has 3D. It has values from 3D1 to 3D10.
Yes, I mean that is correct. A proper way of and a better statement would be we fill the electrons in the d subshell. That is why it is named 3D series. Okay.
Yes, sir.
Now, what is after this? Have you written this second year law AC, right? Then this is T zara half. I mean, you don't need so much of T in every time. So you just T zara half. And this is vanadium. Okay. This is vanadium. This is NB. Okay, fine. I have to write the names. ZR is zirconium. Zirconium. What is this? This is hafnium. This, oh no, hafnium does not have LF. It has HAF, half, and nium. And NB is niobium. And this is Ta. This is Ta. This is tantalum. Wait a second. It is tantalum. Tantalum. Yes. T's are a half, and for this we have wo Nawab tha. You remember your old friends, like, I mean, he used to have so much of tantrums, right? Then who have tantrums? Nawabs have tantrums, right? Then we have chromium, the chromium series. We'll remember it as MO. This is molybdenum. Molybdenum. After molybdenum, we have, wait a second. We have W. Yuvraj, what is the name of this element? W?
Sir, W.
No idea, right? Now I'm giving you some hints. Okay. Just invert this W and write it in a fancy way. Can you write it in a fancy way like this?
Yes, sir.
Okay, fine.
The tungsten.
Yes, see, easy to remember, right?
Yes, sir.
This is tungsten, right? How to remember this? I don't know why, but it is just crow chromaton, chromaton, chromaton doesn't make any sense, but I have remembered it like this, chromaton. Okay. Then we have manganese here. Then we have Tc. We have here Tc. The name of Tc is very nice. It is Techni. Tech. I should have made some more space. I'm just regretting this now. Technetium. It is technetium. I think I should write it. This is technetium. Technetium. And after technetium, what do we have? Tak ray. Man tak ray. Re. What is Re? Rhenium.
Rain.
Rhenium.
Yes, sir.
And how to remember this? Writing this here. Man tak ray. I mean, there are some things that you should just keep in your heart, and you should not express those things, right? There are at times one should not express everything. I mean, when times come, then you should express those things, but sometimes you have to wait. Now for Fe is very easy. The other thing, what is the full form of Fe, if you know?
Sir, full form of?
Fe. I mean, Fe does not correspond with iron, right? Iron has Ir, but Fe has
Yes, sir. Sir,
F and E.
ferrous. Ferrous.
So yeah, you remember ferrous, right? You just have to remember that only. See, you told me, so I'm writing ferrous. That is the trick here. What is OS? OS will be osmium. This will be Ru will be
Sir,
ruthenium.
Ruminium.
Ruthenium.
Ruthenium.
Okay. So how to remember this? Fe Ruos. OS. Ruos. Now we have got cobalt. Cobalt, and this will be Rh. What is Rh? Rh is rhodium. Rhodium. Okay. And after Rh, we have here Ir. Ir is iridium. How will you remember this? You will remember this with this IR. Any country that you can name with IR that starts with IR,
Sir,
it means,
Ireland.
sorry?
Ireland.
Yes.
कौन रहेगा Ireland?
Okay, fine. I mean, everybody, I guess, would want to live there, but still, let us see. And now you will resonate so much with these elements. Nickel, then we have palladium. Where have we seen palladium before?
Sir, this word. Don't remember.
Palladium. You don't remember?
No, sir.
Palladium and thorium are the two elements in the exceptional electronic configuration which transfer two electrons. Now, do you remember?
Yes, sir. Thorium and palladium.
The first point of exceptional electronic configuration was, what was the first point? The first point was, if we have the s subshell and the d subshell, then the electron transfers from s subshell to d subshell. The next point of the exceptional electronic configuration was, if we have the s subshell and the f subshell, then electron will transfer from f subshell to d subshell. The third point was there are two elements. What are those two elements? Those two elements are palladium and thorium. These two elements do not transfer one electron, they transfer how many electrons? Two electrons. The
Good.
rest 18 out of 20 exceptional cases, they transfer one electron. Just a bit of revision here. Now, what is the atomic symbol for palladium? It is Pd. Palladium is Pd.
Mhm.
And then we will have Pt. Pt is platinum.
Platinum.
Platinum. So how will you remember this? You will remember this. I'm writing it here. Just ask me, just answer me this. I mean, do you have any difficulties in studying? I mean, sit in a table and chair and start studying.
Sir,
You have some difficulty, or so what you will say, sir, nahi pad pata. I cannot sit for 2 hours. You cannot sit for 2 hours. That is the thing. And you will remember this nickel, palladium, and platinum. And if you remember nickel, palladium, as soon as you played here palladium, just remember his brother thorium. And
yes.
if you remember these two, then you will okay fine S and D and S and F always the electron always goes to D. It doesn't care whether it is coming from S or F. It comes from S if it is from the D block elements. It comes from F if it is from the F block elements, but it always go to D. And it goes one electron in 18 elements, and in two, that is palladium and thorium, it goes transfer of two electron take place. Now the copper one. Now tell me, do you know coins, right? Coins, we have 1 rupee coin, 2 rupee coin, but in earlier times coins were of not steel.
Sir, obviously, sir, yes. So you aren't told.
I am really sorry, the internet snapped. I don't know how. Okay, you were not able to, I guess, write all those things, na?
No, sir, I did.
You have written?
Yes, sir.
Okay, great. So, what did we have? We were about copper, right?
So we
I
were
was
at
asking
last.
about the sorry.
So we were on the last two lines.
Yes, last 2 lines. What we were talking about? We were talking about coins. Yes,
Yes,
coins.
sir.
We had gold coins. We had silver coins, right?
Yes, sir.
So that is the elements here. Copper. Then what will you have here? What are those things?
So gold and silver.
Yes. Then you will have Ag for silver and Au for gold. Okay.
Yes, sir.
Then what you have? You have here zinc, then cadmium, then mercury. Cadmium, mercury. I mean, for this you can just remember as क्यों आगे आऊं. Most of the time people don't come forward when you need them, right?
Yes, sir.
right? So I mean, in their head, that must be going. But the last, you have to remember this: zinc, cadmium, and mercury. Now, the last thing I will tell, and I will end this class. I mean, the snapping of internet was, I guess, a reminder that I have to end the class, and I have taken too much of your time. Okay, fine. The only thing that I will had to mark this before. What is this? This is which element?
So this is tungsten.
Tungsten. You will remember tungsten. Why you will remember tungsten? You will remember that it is tungsten and it was used in the filaments. And if it is used in the filaments, it will have very high melting point. Okay, this element, and you have to remember two more: osmium and iridium. They are just next to each other. Okay, osmium, iridium, most dense elements. Okay,
Yes, sir.
and that's that. If you want to write these things, please note it down. We will meet in the next class. We will deal with the F block and will touch the surface of the S block elements, and we will learn the five most important properties that determine the nature of any element. What are those properties? Just remember: Z effective, atomic radius. I mean, these two, I guess, we will cover in the next class, and the rest we will cover in the next class. The next are ionization enthalpy, electron gain enthalpy, and the electronegativity. Okay?
Yes, sir.
Okay, fine. So, have you noted all this down?
1 minute.
Okay, please note it down. You don't have to write these things. I mean, these are just about the next. Don't have to write this.